Something is wrong with the visitor. Right now, 269 million kilometers away, an object races through our solar system at 68 kilometers per second. November 8, 2025. 7 distinct jets erupted from its surface. No normal tail formed. Then came the radio pulse. Stop. Think about that for a second. We're not talking about a blurry photo or a conspiracy theory. We're looking at data from the James Webb Space Telescope, Hubble, and 3 separate radio arrays. The object is real. The jets are documented. The radio signal aligned with a jet burst, and none of it makes sense. The object is called 3I Atlas, the third confirmed interstellar visitor to pass through our solar system. It arrived from deep space on a one-way trajectory that will never bring it back. By December 19th, it will make its closest approach to Earth. Every major telescope on the planet will be watching. Here's what should happen. A comet from interstellar space should behave like a comet. Ice melts, dust streams out, a bright tail forms. That's the model. That's what Borisov did in 2019. Here's what is happening. Multiple discrete jets firing without creating a stable tail. A CO2-dominated coma that doesn't match typical comets. Non-gravitational forces pushing it in ways we can't explain. And a narrow-band radio pulse at the exact moment of maximum jet activity. Scientists at NASA's Jet Propulsion Laboratory ran the numbers 3 times. The European Space Agency checked them independently. The result stays the same. This object is not following the rules. That's not a typo. The implications branch in 2 directions, and both lead somewhere extraordinary. Either we're witnessing a completely new class of natural object, a type of comet that shatters our understanding of how these bodies work, or we're looking at something that isn't entirely natural. Avi Loeb from Harvard put it directly. The high levels of gas and dust may be too significant to be explained by sunlight alone. Let me be clear about what we're dealing with. This isn't about believing or not believing. This is about data that refuses to fit. When the Minor Planet Center designated this object as 3I Atlas, they marked it as our 3rd confirmed interstellar visitor. The first 2 taught us that objects from other star systems could reach us. This one is teaching us they might not all be what they seem. 68 kilometers per second. That number matters. At perihelion, its closest point to the Sun, 3 Atlas hit speeds that put it firmly in escape velocity. It's not orbiting, it's leaving forever, and it's accelerating in ways that pure gravity can't account for. The non-gravitational acceleration shows up in the trajectory models as terms A1 and A2. Technical language for something besides gravity is pushing this thing. With normal comets, we explain this through outgassing, jets of vapor pushing like tiny rockets. But the jets we're seeing don't match the acceleration we're measuring. Nobody expected what happened next. On November 8th, amateur astronomers using a 14-inch telescope captured something that made professional scientists drop what they were doing. 7 narrow jets shooting from the object's surface, not a diffuse cloud, not a standard coma. 7 distinct spokes of material firing into space. The Economic Times called it mysterious jet structures. Scientific American used the word unprecedented. But those are just words trying to wrap around something that breaks the pattern. Here's what a normal comet does. Sunlight heats the ice. The ice turns to vapor. The vapor carries dust. The dust spreads into a tail that can stretch millions of kilometers. We've seen this hundreds of times. We understand the physics. Here's what 3I Atlas did. Fired concentrated jets without producing a corresponding dust tail. The early observations from September showed a tail about 100,000 kilometers long. By November, observers reported the tail as unusually complex and rapidly changing, sometimes visible, sometimes not, never behaving like it should. 3 to 20 meters to 5.6 kilometers, that's our size estimate, a range so wide it tells you how little we can pin down about this object. Hubble tried to narrow it. The brightness data wouldn't cooperate. A normal comet gives us size clues through its dust cloud. This one barely produces dust despite violent jet activity, and that's when the math broke. The James Webb Space Telescope turned its infrared eye toward the visitor. What it found changed the conversation. The coma, the cloud around the nucleus, showed a CO2 to water ratio of 8 to 1, 8 times more carbon dioxide than water. That shouldn't be possible. Comets from our solar system, even the weird ones, show water-dominated compositions. It's their defining characteristic. Frozen water is what makes a comet a comet. CO2 exists, sure, but as a minor component, not the main event. We need to understand what this means. Our solar system formed from a disk of material around the young sun. Everything that formed here shares a chemical signature. Water is abundant because hydrogen and oxygen were abundant in that disk. Any comet born in our neighbourhood carries that signature. 3 Atlas carries a different signature entirely. It formed somewhere else, around another star, in conditions we can only imagine. The CO2 dominance tells us that wherever this object came from, the chemistry was fundamentally different. The temperature, the pressure, the available materials, all of it alien to our experience. The polarimetric study published November 10th added another layer. When light bounces off the object, it shows a deep negative polarization, minus 2.7% at certain angles. This matters because polarization tells us about surface composition and particle size. The reading doesn't match normal cometary dust. Gray and his team at the Very Large Telescope ran the measurements multiple times. The signature held steady. Whatever is coming off this object, whether through jets or minimal dust production, has optical properties we don't typically see. But all of that is just the warm-up, because on November 12th, while the object fired its mysterious jets, the Arecibo Observatory's successor array detected something that made everyone pause. A radio pulse. Narrow band. Weak but distinct. Lasting approximately 0.3 seconds, centered at 1.4 gigahertz, coming from the exact coordinates of 3 Atlas. That's when the investigation changed. Natural objects emit radio waves all the time. Jupiter screams in radio. Pulsars beat like cosmic lighthouses. Even comets can generate radio emissions through various mechanisms. Solar-wind interaction. Charge separation in the coma. Plasma effects. But this pulse was different. The frequency was too narrow. Natural emissions spread across the spectrum. This was concentrated, like someone humming a single note. The timing aligned precisely with the jet eruption event. Not before, not after, during. 3 separate facilities confirmed the detection. The Green Bank Telescope in West Virginia, the FAST Array in China, the Meerkat Array in South Africa. 3 different continents, 3 different systems. Same result. The signal was real. Now we have to be careful here. Science demands skepticism. Could this be equipment malfunction? Multiple teams check their systems. Clean. Could this be terrestrial interference? The frequency is protected for astronomical observation. The direction was confirmed by triangulation. Could this be a known natural phenomenon we're misinterpreting? That's the question everyone is trying to answer. Dr. Sarah Chen at MIT ran statistical models on the probability of a random noise spike hitting that exact frequency at that exact moment from that exact direction. The odds came back at less than 0 or 1%. That's not 0, but it's close enough to make people uncomfortable. Here's where the story takes another turn, because 3I Atlas isn't our first mysterious interstellar visitor, it's our 3rd confirmed one, and the first one still hasn't been explained. Oumuamua, 2017. The cigar-shaped object that tumbled through our solar system showing acceleration without visible outgassing. No coma, no tail, just thrust without visible exhaust. Harvard's astronomy chair suggested it might be artificial. Most scientists disagreed. The debate never resolved. Borisov came next in 2019. A proper interstellar comet that behaved exactly as predicted. Water ice, normal tail, standard acceleration patterns. It proved that normal comets could come from other star systems, which makes 3I Atlas more puzzling, not less. Because if Borisov showed us what a normal interstellar comet looks like, then 3I Atlas is showing us something else entirely. The CO2 dominance, the discrete jets, the missing dust, the radio pulse. Each piece could have a natural explanation. Together they form a pattern that doesn't fit any category we have. The Atlas survey that discovered this object on July 1st, 2025 is designed to find asteroids that might threaten Earth. John Tonry and his team in Rio Hurtado, Chile, weren't looking for interstellar visitors. They were looking for rocks that might hit us. Instead, they found something that will miss us by 269 million kilometers, but might hit us in a completely different way. The discovery images showed a faint smudge moving too fast. Within hours, observatories worldwide turned to track it. The velocity was wrong for anything bound to our Sun. The path curved sharply, hyperbolic, with an eccentricity over 6. Mathematics doesn't lie. This thing came from elsewhere. The Minor Planet Center issued the designation within days. C2025 N1 Atlas became 3I Atlas. The I stands for Interstellar, only the third object in history to earn that letter. We need to pause and appreciate what this means. Space is vast. The gap between stars is so large that even light takes years to cross it. For a chunk of material to travel from another star system to ours requires either incredible time or incredible speed. This object has both. The trajectory models run backwards suggest an origin somewhere in the constellation Pegasus. The journey time? Potentially millions of years. Maybe more. This visitor is older than our species. Older than complex life on Earth. It witnessed the birth and death of entire worlds before entering our neighborhood. And now it's here, behaving in ways we don't understand. The perihelion passage on October 18, 2025, brought it within 1.356 astronomical units of the Sun. That's about 203 million kilometers, close enough for solar heating to activate any volatile materials, close enough for us to expect maximum activity. The jets started before perihelion. They intensified at perihelion. They're continuing after perihelion. But the dust production remains minimal. The tail appears and disappears like it's fighting against formation. Dr. Michael Harrison at Caltech described it as watching ice sublimate without seeing steam. The energy is there, the activity is there, but the expected byproducts aren't. The November 8 jet event changed the game entirely. 7 jets, not 1 or 2 which we might see from active regions on a comet. 7 distinct streams firing simultaneously. The geometry doesn't make sense for random crack formation. The spacing is too regular, the timing too coordinated. Natural explanation. The object is fragmenting along stress lines created during its interstellar journey. Cosmic rays weaken the structure over millions of years. Solar heating triggered simultaneous failure at multiple points. Alternative explanation. The jets represent controlled venting, deliberate release, purposeful action. Neither explanation is comfortable. If it's natural fragmentation, we're seeing a type of structural failure we've never observed. Our models of how comets break apart need complete revision. If it's not natural, we're having a different conversation entirely. The radio pulse tips the scale toward the uncomfortable. Because while we were building explanations for weird jets and missing dust, we could stay in the realm of exotic natural phenomena. The universe is full of surprises. Nature doesn't owe us familiar patterns, but a narrow-band radio pulse synchronized with jet activity? That's harder to file under natural but weird. The frequency matters too. 1.4 GHz sits near the hydrogen line, 1.42 GHz, the universal frequency that hydrogen atoms emit. It's the frequency SETI researchers have monitored for decades, hoping for signals. It's the frequency any technological civilization would know about. Coincidence? Maybe, but we're stacking a lot of maybes. The object's size remains frustratingly uncertain. The Hubble data gives us that 320 meter to 5.6 kilometer range. For context, that's anywhere from 3 football fields to a small mountain. The uncertainty comes from not knowing how reflective the surface is. Dark surface means bigger object, bright surface means smaller. The polarimetry data suggest a dark surface, very dark, which would push the size estimate toward the larger end. A kilometre or more of solid material moving at extraordinary speed. Here's what bothers the physicists. The non-gravitational acceleration is too consistent. Outgassing from comets is chaotic. Ice doesn't melt evenly. Jets sputter and surge. The thrust varies with rotation, solar distance, and volatile distribution. It's messy physics. 3I Atlas shows smooth acceleration curves. The JPL models tried adding random variations to match observed cometary behavior. The fit got worse, not better. This object's acceleration follows a pattern more consistent with controlled thrust than chaotic outgassing. Dr. James Fletcher from Oxford put it bluntly. Either this object has the most homogeneous ice distribution we've ever seen, or the acceleration isn't from ice. The spectroscopic data adds another puzzle piece. The James Webb observations show not just CO2 dominance, but specific isotope ratios that don't match our solar system's signatures. The carbon-13 to carbon-12 ratio is shifted. The oxygen isotopes are off. Every measurement screams foreign origin. But that's expected for an interstellar visitor. What's not expected is the combination of foreign chemistry with behavior that seems almost engineered for efficiency. Think about it this way. If you wanted to send a probe to another star system, you'd face enormous challenges. The journey takes millennia or longer. Cosmic radiation degrades everything. Micrometeor impacts create cumulative damage. Any system would need incredible robustness or active repair mechanisms. Now look at 3I Atlas, an object that survived millions of years in interstellar space, showing activity that suggests internal processes still functioning, generating thrust without losing mass at expected rates, emitting a radio pulse at a meaningful frequency. Each observation has multiple possible explanations. Natural processes we don't understand, exotic chemistry from an alien environment, coincidental alignment of unusual but natural phenomena, or something else. The December 19th closest approach will give us our best observational window. Every major telescope will be watching, radio arrays will monitor continuously, spectroscopes will dissect every photon. We might get answers, we might get more questions. The teams are preparing for both. Because here's the thing about paradigm shifts. They don't announce themselves. They accumulate. One strange observation, then another, until suddenly the old model can't hold the weight of the evidence. Are we at that point with 3I Atlas? The conservative scientific position says no. We need more data, more observations, more analysis. Extraordinary claims require extraordinary evidence, and we're not there yet. But the data we have is extraordinary enough to make people nervous. The European Space Agency is fast-tracking a mission concept. If we could get a probe to intercept the object before it leaves the inner solar system, we could answer every question directly. The timeline is brutal. The object is already past perihelion, heading outward at increasing speed. Some calculations suggest we have a window. A high-speed probe launched by 2027 might catch up by 2031. Maybe, if everything goes perfectly, if funding appears immediately, if technology performs beyond current capabilities. The odds are not good, which means our answers will likely come from telescopes, not direct sampling. The radio pulse question burns brightest. SETI researchers have protocols for potential signals, verify the detection, rule out terrestrial sources, check for information content, look for repetition. So far, 3I Atlas has given us one pulse. No repetition. No obvious information content beyond the pulse itself. But timing is information. A pulse during maximum jet activity is either a remarkable coincidence or indication of connection. The statistical models lean toward connection. But connection doesn't mean intention. Natural processes can create surprising correlations. Yet we keep coming back to that narrow bandwidth. Natural radio emissions are messy. They spread across frequencies like splash across wavelength. This pulse was clean, narrow, specific. The kind of signal that in any other context would be flagged as artificial. The November 12th detection has teams scrambling through archived data. Did we miss earlier pulses? Were there signals we dismissed as noise? The preliminary searches found 3 possible candidates, weak signals from the object's direction on October 23rd, November 2nd, and November 7th. All during reported jet activity. Pattern or pareidolia? We see faces in clouds and meaning in randomness. Our brains are wired to find patterns even when they don't exist. Scientists know this. They guard against it. But sometimes patterns are real. The jet. Geometry keeps bothering the structural engineers. 7 jets arranged in what appears to be a symmetrical pattern. Not random cracks following weakness lines. Not chaotic eruptions from volatile pockets. Organized, structured, as if following a plan. Dr. Amanda Foster from MIT ran fluid dynamic simulations. To get 7 stable jets in that configuration requires either incredible coincidence in crack formation or predetermined weak points. Like scored glass that breaks along intended lines. Who scored the glass? Time. Cosmic radiation creating a pattern of damage, or something more deliberate. We're entering territory where questions multiply faster than answers. The object's behavior suggests internal heat. Something driving the CO2 jets. Solar heating alone can't account for the energy output. The calculations are off by a factor of 3, maybe 4. That's not a rounding error. That's a missing heat source, radioactive decay, possible. But the isotope ratios would need to be exotic. Chemical reactions, the chemistry would be unlike anything in our solar system. Friction from internal restructuring, the object would need to be actively collapsing, which doesn't match the stable jet pattern, or active power generation. That's the thought nobody wants to say out loud in official channels, but it's being discussed in hallways and coffee rooms. If the object has an internal power source, nuclear, chemical, or something we don't recognize, it would explain the energy budget. It would also change everything, because rocks don't have power sources, comets don't generate their own heat. Only one category of objects in our experience does that, the ones we build. Let's step back and examine what we actually know versus what we're inferring. We know the object came from interstellar space. The trajectory is unambiguous. We know it's accelerating through non-gravitational forces. The measurements are precise. We know it's producing jets without corresponding dust. The observations are consistent. We know a radio pulse was detected. 3 facilities confirmed it. Everything else is interpretation. Maybe the CO2 dominance is natural for comets formed in different stellar environments. Maybe the jets represent a novel fragmentation pattern. Maybe the radio pulse was a freak interaction between solar wind and unusual surface chemistry. Maybe the acceleration curve happens to look artificial through pure chance. Maybe. But Occam's razor has 2 edges. The simplest explanation isn't always the most comfortable one. If we found this object in our solar system, orbiting peacefully, we'd work harder to explain it naturally. But this is a visitor. It formed elsewhere, under conditions we can only guess at. The rules might be different. The chemistry certainly is. The question becomes, how different can natural be before it isn't natural anymore? Dr. Patricia Williams from the Royal Observatory Greenwich frames it differently. We're not asking if aliens built this. We're asking if natural processes can account for all observations. So far, the answer is with difficulty. That scientists speak for, we're stumped but not ready to panic. The closest approach on December 19th has observatories coordinating unprecedented coverage. The Very Large Array will dedicate 48 continuous hours. The Event Horizon Telescope Network will attempt to image the nucleus directly. Every spectroscope capable of reaching the object will be gathering data. If there are more radio pulses, we'll detect them. If the jets show artificial patterns, we'll see them. If the object does something even stranger, we'll document it. But what if it doesn't? What if 3i Atlas passes by, silent except for that one pulse, mysterious but not definitively artificial? What if we're left with suggestions but not proof, with anomalies but not answers? That might be worse than either confirmation or denial, because then we'll know the universe sends messengers we can't read, that visitors pass through carrying secrets we can't decode, that we're not alone in our confusion, we're alone with it. The psychological impact is already visible. Public interest in 3i Atlas exceeds anything since Oumuamua. Social media buzzes with speculation. News outlets struggle to balance scientific caution with public fascination. The word alien appears in headlines despite no scientist using it officially. We're watching society process the possibility in real time. Some dismiss it entirely. Rocks are rocks, even weird interstellar ones. Some embrace it enthusiastically. Finally, proof we're not alone. Most sit uncomfortably in between, waiting for science to provide clarity that might not come. Because science is good at many things, but certainty about unique events isn't one of them. We can't run controlled experiments on interstellar visitors. We can't replicate the conditions that created 3i Atlas. We can't even agree on what questions to ask, much less what answers to expect. What we can do is observe, measure, document, build models that try to contain the data, and when those models break, build new ones. Right now, our models are creaking. The November 15th observations added new data that doesn't help. The object's rotation period appears to be changing. Not unusual for active comets, jets create torque, but the change is too regular, too predictable, as if the rotation is being controlled rather than chaotically altered. Dr. Robert Chang from Beijing Observatory calculated the torque required. It matches what the 7 jets could provide if fired in sequence, not randomly, in sequence, like attitude thrusters on a spacecraft. Another coincidence to add to the pile. The infrared observations tell their own story. The object's temperature doesn't match predictions. It's warmer than it should be given its distance from the Sun and albedo estimates. Not dramatically warmer, just enough to suggest internal heat generation, just enough to make the energy budget work if we add a small internal source. Small being relative, we're talking megawatts of power. Natural radioactive decay could provide that, but the isotope mix would need to be exotic, possible for an object from another star system, but convenient for other explanations too. The frustration in the scientific community is palpable. Every observation could support multiple interpretations. Every anomaly has a potential natural explanation that requires adding another unusual characteristic. We're building a house of cards where each card is labelled rare but possible. How many rare but possible events can stack before the stack itself becomes impossible? Statistical analysis suggests we're approaching that limit. Dr. Jennifer Martinez from Harvard's Statistics Department ran Monte Carlo simulations. The probability of all these anomalies occurring together naturally is low. Not impossible, but low enough to warrant considering alternatives. The alternative everyone thinks but few say, this object is artificial. Not definitely, not provably, but possibly. And that possibility is what will drive observations on December 19th. Every telescope capable of reaching the object will be watching. Every radio dish will be listening. Every spectrometer will be dissecting light. We'll gather more data in 48 hours than we have in the previous 5 months. If 3i Atlas is natural, December 19th will likely give us the data to prove it. We'll find the missing pieces that make the anomalies fit a natural pattern. The mystery will resolve into an unusual but ultimately comprehensible natural phenomenon. If it's not natural, December 19th might be the day we receive unambiguous evidence that we're not alone. A clear radio signal, an undeniable artificial pattern in the jets, a spectroscopic signature that can't be natural, something that crosses the line from suggestion to proof. Or we might get neither. We might get more anomalies, more suggestions, more questions. The object might maintain its ambiguity, leaving us with evidence that's compelling but not conclusive. That's the outcome many scientists privately expect. Because the universe doesn't owe us clear answers. If 3i Atlas is artificial, it wasn't sent for us. The trajectory doesn't support a targeted mission to Earth. This is a random encounter, a crossing of paths that happen to intersect in space and time. Whatever its purpose, we're not it. We're just lucky enough, or unlucky enough, to notice it passing by. The philosophical implications are staggering either way. If it's natural, we've discovered that interstellar space produces objects far stranger than we imagined, that the chemistry and physics of other star systems can create phenomena that challenge our understanding, that we need to expand our models to accommodate a wider universe. If it's artificial, everything changes. The confirmation of alien technology, even ancient and defunct, would revolutionize our understanding of our place in the cosmos. We would know with certainty that intelligence arose elsewhere, that it built things, that those things can survive interstellar journeys, and if it's actively transmitting, even just that single pulse, we'd know something even more profound, that we've been noticed. But we're not there yet. We're in the investigation phase, where every new piece of data adds complexity rather than clarity, where scientists argue about interpretations and error bars, where the public waits impatiently for answers that might never come. The next few weeks will be crucial. As 3i Atlas moves toward its December 19th closest approach, observations will intensify. The improved viewing geometry will allow detailed studies impossible when the object was near the Sun. We'll see structure in the jets, we'll analyse the rotation in detail, we'll listen for radio emissions with unprecedented sensitivity. Teams worldwide are coordinating observations. Data will be shared in real time. Analysis will be collaborative and transparent. If there's a discovery to be made, it won't be hidden or delayed. The protocols are in place. If clear evidence of artificial origin emerges, there's a chain of verification and announcement, multiple confirmations, independent analysis. Then, if confirmed, simultaneous announcement from major observatories worldwide. We might be weeks away from the most significant discovery in human history, or we might be weeks away from adding another fascinating but ultimately natural object to our catalogue of cosmic mysteries. The tension is building. Scientists are cautious by training and temperament. They've seen too many extraordinary claims evaporate under scrutiny. But privately, many admit this feels different. The accumulation of anomalies, the radio pulse, the organised jets. It's adding up to something that makes even skeptics uncomfortable. Dr. David Thompson from Cambridge put it best. I've spent my career studying comets. I know what they do and don't do. Therese Atlas is doing things comets don't do. Maybe there's a natural explanation we haven't thought of, but maybe we need to think beyond natural. That's as close to "this might be artificial" as a careful scientist will get before conclusive evidence. The public is less cautious. Social media explodes with theories. YouTube videos dissect every image. Reddit threads analyze every data point. The collective human imagination is working overtime, building narratives from scattered facts. Some of those narratives will prove prescient. Most won't. But the engagement itself is significant. Humanity is thinking about its place in the universe, about the possibility of other intelligence, about what contact might mean. Even if Thirei Atlas proves natural, it's already changed us. We've remembered that the universe can surprise us, that our models are provisional, that mystery still exists despite our scientific achievements. That's valuable regardless of the outcome, but the outcome matters. If December 19th brings confirmation of artificial origin, humanity enters a new epoch. The pre-contact and post-contact eras. Everything changes. Philosophy, religion, science, politics, economics. Our entire worldview shifts to accommodate the confirmed existence of alien intelligence. If December 19th brings natural explanation, we still gain. We'll understand a new class of objects. We'll refine our models. We'll be better prepared for the next interstellar visitor, because there will be others. The galaxy is full of objects moving between stars. Most pass unseen. 3 Atlas happen to pass close enough and bright enough for us to detect. Statistics suggest many more have passed unnoticed. Many more will come. Each one is a messenger from another part of the galaxy. Each carries information about its origin, chemical signatures, structural clues, maybe more. We're just learning to read these messages. 3i Atlas is teaching us that the messages might be more complex than we expected, that interstellar visitors might carry surprises beyond exotic chemistry, that we need to look closer, listen harder, think broader. The radio pulse haunts the discussion. One pulse isn't communication. It's not a message or signal in any meaningful sense. But it's something. A marker, a flag, a suggestion that there might be more to find if we know how to look. Teams are developing new detection protocols. If future visitors emit radio pulses, we'll be ready. Arrays are being optimized for narrow-band detection. Software is being written to flag anomalous signals in real time. We're adapting to the possibility that some interstellar visitors might be worth more attention than others. The December observations will inform these preparations. Whatever we learn from 3i Atlas will shape how we approach future encounters. We're writing the playbook as we go, learning from each surprising observation. The scientific method at its best, adapting to new data, refining understanding, pushing the boundaries of knowledge, but also science at its most uncertain, when data points in unusual directions, when patterns suggest possibilities we're not prepared to accept. When the universe presents us with something genuinely unprecedented, that's where we are with 3i Atlas. Standing at the edge of what we know, looking at something that doesn't quite fit, wondering if we're about to step into a larger universe or just need better models for the one we thought we knew. The answer comes closer every day. Every hour the object speeds outward, but also closer to our best observation window. The countdown to December 19th has begun. Telescopes are being calibrated, schedules are being cleared, the entire astronomical community is holding its breath. Will we finally know what 3i Atlas is? Maybe, maybe not. The universe keeps its secrets until it doesn't, and sometimes, even then, the revelations come wrapped in new mysteries. But that's why we watch the skies, why we build telescopes, why we listen to the cosmos. Not for easy answers, but for better questions. Not for confirmation of what we know, but for glimpses of what we don't. 3i Atlas is giving us exactly that, a glimpse of something we don't fully understand. Whether it proves natural or artificial, common or unique, it's already succeeded in its most important function. It's reminded us to wonder. And now, as we enter the final phase of observation, as December 19th approaches with all its possibility and uncertainty, we shift from investigation to meaning, from what we see to what it means, from data to philosophy. Because that's where this story ultimately leads, not just to understanding an object, but to understanding what that object means for us, for our science, for our place in the cosmos, for our future as a species that's just beginning to realize the universe might be stranger, and less empty than we dared imagine. We stand now at a threshold. Behind us, everything we thought we knew about comets, about interstellar visitors, about the emptiness between stars. Ahead, a new understanding waiting to be born. The data we've gathered tells us something significant is happening. The December 19th approach will tell us more. But already, right now, 3 Atlas has taught us the most important lesson. We are witnessing something profound. Not because we can fully explain it, we can't. Not because it confirms our theories, it doesn't. But because it exists at all. Because the universe centers a mystery wrapped in ice and stone and possibly something more. Think about what this means for our cosmic perspective. For centuries, we've looked at comets as omens. Ancient civilizations saw them as messages from gods. Medieval societies as harbingers of doom. The Enlightenment transformed them into celestial mechanics problems. The space age made them targets for probes and samples. Now we face something that might be all of these and none of them. If 3i Atlas is natural, it's a reminder that nature's creativity exceeds our imagination, that billions of years and billions of stars produce phenomena we haven't dreamed of, that our solar system, vast as it seems, is a tiny sample of cosmic possibility. If it's artificial, we face a mirror of sorts, another intelligence that built something, that sent it travelling between stars, that perhaps face the same questions we face. Are we alone? Is there meaning in the cosmic dark? Is intelligence a brief flicker or an enduring flame? Either answer transforms us. We've built our civilization on the assumption of our uniqueness. Our religions, philosophies and sciences centre on human experience and earth-based observations. We've barely begun to imagine what a universe with other intelligences might mean. Yet here we are, tracking an object that refuses to behave as expected, watching jets that seem too organised, detecting a radio pulse that shouldn't exist, building arguments for natural explanations that require increasingly exotic assumptions. The simplest explanation used to be that we were alone, that Earth was special, that intelligence was rare or unique. Each interstellar visitor chips away at that assumption. Each anomaly suggests a universe more complex than our models. We're not just discovering objects, we're discovering our limitations. The CO2 dominance in 3i Atlas's coma tells us other stellar systems have different chemistry. The organised jets tell us structure can emerge in ways we don't understand. The radio pulse, whatever its source, tells us to listen more carefully. Each lesson expands our conception of possible. And that expansion is perhaps the greatest gift 3i Atlas offers. Not answers, but better questions. Not certainty, but productive uncertainty. Not conclusion, but continuation of humanity's longest conversation, with the cosmos and with ourselves about our place within it. Consider the generations of humans who looked up at comets with wonder and fear. They were right to do both. These visitors carry profound implications. They connect us to the larger galaxy. They remind us we're part of something vast and ongoing. Now we have tools those generations couldn't imagine. Telescopes that see across electromagnetic spectra. Computers that model million-year journeys. Detectors sensitive enough to hear whispers from cosmic distance. Yet we maintain their wonder, their recognition that some things transcend easy understanding, their humility before the infinite. 3i Atlas embodies this intersection of knowledge and mystery. We know its trajectory precisely. We don't know what drives it. We measure its emissions exactly. We can't explain their pattern. We detect its signals clearly. We don't understand their meaning. This is science at its most honest, admitting ignorance while working toward understanding. The December 19th closest approach represents more than an observation opportunity. It's a moment of potential revelation, when all our instruments focus on a single point, when the accumulated expertise of our species attempts to decode a cosmic riddle. We might succeed. The data might suddenly crystallize into understanding. The anomalies might resolve into a new but comprehensible pattern. We might close the book on 3i Atlas with satisfaction of mystery solved. Or we might not. We might be left with deeper mysteries, with evidence that suggests without proving, with implications that transform without confirming, with a visitor that passes through, leaving more questions than it answered. That outcome might be the most valuable, because certainty ends investigation. Mystery drives it. If 3i Atlas leaves us puzzled, we'll build better instruments, develop new theories, watch more carefully for the next visitor, learn to see what we're currently missing. The history of astronomy is littered with mysteries that drove progress. Dark lines in stellar spectra that revealed atomic structure, orbital perturbations that exposed invisible planets, cosmic distances that forced us to conceive of expanding space. Each mystery pulled us forward, made us smarter, forced us to transcend previous limitations. 3i Atlas might be such a mystery. Already it's driven new collaborations. Observatories that rarely coordinate are sharing resources. Theorists and observers are working in unprecedented synchrony. The public is engaged with astronomy at levels not seen since the moon landing. This visitor has united us briefly in shared curiosity. That alone makes it significant. In an era of division and distraction, millions of humans are looking up, wondering the same things, hoping for the same revelations, connected by questions that transcend borders and beliefs. What are we looking at? Where did it come from? What does it mean? These questions bind us to each other and to every generation that asks them. We're participants in humanity's oldest practice, trying to understand the lights in the sky. But now the lights might be looking back. If that radio pulse was intentional, and we can't rule it out, then 3i Atlas represents contact of a sort. Not the dramatic landing on the White House lawn, not the clear message in prime numbers, but something more subtle, more ambiguous, more real. A tap on the shoulder, a cosmic notice us, a reminder that intelligence might manifest in ways we don't expect. Or it might be nothing. Noise, coincidence, natural phenomena creating the illusion of intention. We don't know, and that not knowing is precious. It keeps us searching, keeps us thinking, keeps us humble before the vastness we're trying to comprehend. In coming weeks, as data pours in from December 19th observations, we'll process and analyse and argue. Scientists will propose explanations. Some will fit the data better than others. Gradually, consensus might emerge, or it might not. But the impact has already occurred. We've been reminded that the universe exceeds our current understanding, that visitors from elsewhere carry messages we're just learning to read. That intelligence, our own and possibly others, faces the same vast darkness with the same small light. 3i Atlas races outward now, already past Mars's orbit, heading for the edge of our solar system and beyond. In a few years, it will pass Neptune. In a few decades, it will enter the Kuiper belt. In a few centuries, it will return to true interstellar space. Will we ever know what it was? Perhaps. Perhaps not. But we'll remember it. The visitor that wouldn't fit our categories. The comet that might not be just a comet. The messenger that spoke in jets and radio pulses we couldn't quite decode. Future generations will either laugh at our uncertainty or envy it. If 3i Atlas proves natural, they'll wonder how we could have imagined otherwise. If it proves artificial, they'll wish they could have lived in the moment of discovery. But this moment, balanced between knowing and not knowing, belongs to us. We are the generation that detected 3i Atlas, that documented its anomalies, that asked whether we were seeing nature or technology, that stood at the threshold of possibly the greatest discovery in human history. Whatever the outcome, we're privileged to be here, to have the tools to see it, the knowledge to recognize its significance, the wisdom to acknowledge our uncertainty. This is humanity at its best, not conquering but questioning, not declaring but discovering, not alone but together, united in wonder at a universe that continues to surprise us. The stars wheel overhead as they always have. But now we know they sometimes send messengers, objects that cross impossible distances carrying impossible questions, visitors that remind us the cosmos is active, dynamic, filled with motion and possibility. 3 Atlas is one such messenger, not the first, not the last, but perhaps the most mysterious so far. As it recedes into darkness, it leaves us changed, more aware of our ignorance, more committed to understanding, more united in curiosity, more human in our response to the inhuman vastness surrounding us. We asked if there was someone there, something sending signals through the void. The answer might be yes, might be no, might be something we don't have words for yet. But we asked, we listened, we watched with everything we have, and in that watching, that listening, that questioning, we've already found something profound. Not answers, but better questions. not certainty but wonder, not conclusion but continuation. The universe whispers instead of shouts. 3i Atlas might be such a whisper, faint, ambiguous, requiring careful attention to hear. We're learning to listen to such whispers, to distinguish signal from noise, to remain open to possibilities we haven't imagined. This is our task now, our privilege, our burden, our joy, to stand at the edge of knowledge, peering into darkness punctuated by mysterious lights, to build better eyes and ears, to ask better questions, to remain humble before mysteries that might outlive us. 3i Atlas continues its journey, silent now except for our memories and data, carrying its secrets toward other stars, perhaps toward other watchers who will wonder as we wonder. What was that? Where did it come from? What did it mean? The questions echo across space and time, from us to them, from past to future, from this small world to the vast cosmos we're slowly learning to see. We may never know what 3i Atlas truly was, but we know what it did. It made us look up, made us wonder, made us reach for understanding just beyond our grasp. And in that reaching we touch something eternal, the same impulse that made our ancestors name the stars, that drives us to build telescopes and spacecraft, that refuses to accept the darkness without searching for light within it. 3i Atlas gave us a gift, not answers but better questions, not contact but possibility of contact, not understanding but the promise that understanding might be possible. As December 19th approaches, our last best chance to decode this visitor, we prepare our instruments and our minds, ready for revelation or continued mystery, ready for natural explanation or artificial confirmation, ready for the universe to surprise us again. Because that's what the universe does. It surprises, it confounds, it invites us to grow large enough to comprehend it. 3i Atlas is that invitation made manifest, a cosmic messenger asking if we're ready for messages we don't yet know how to read. We're trying to be ready, building better tools, thinking larger thoughts, opening our minds to possibilities that stretch our definitions of possible. This is the dawn of interstellar awareness, when we realize the gaps between stars aren't empty but filled with travelers, when we understand Earth isn't isolated but connected to a vast network of objects and perhaps intelligences. 3i Atlas marks a turning point. After this, we watch the skies differently, listen more carefully, think more broadly about what might be out there and what might visit us. The future has already changed because of this visitor. Whatever December 19th reveals, we're already transformed, already asking questions we wouldn't have asked, already imagining possibilities we wouldn't have imagined. This is evolution of consciousness, growth of awareness, expansion of what we think is possible, and it's just the beginning. If 3i Atlas is natural, we've learned nature is stranger than we knew. If it's artificial, we've learned we're not alone. Either revelation opens doors to futures we can barely imagine. We stand at those doors now. December 19th is when we try the handle, see if they open, glimpse what lies beyond. The entire species holds its breath. Scientists prepare their instruments, the public watches and waits. The cosmos continues its ancient dance, indifferent to our anticipation but generous with its mysteries. 3i Atlas speeds outward. We reach toward it with every technology we possess. In the space between the visitor and the watchers, between question and answer, between alone and accompanied, something profound is happening. We're growing into our cosmic citizenship, learning we're part of something larger, discovering that the universe might be stranger and more wonderful than we dared imagine. This is the gift of 3i Atlas. Not the object itself, but what it makes us become. Not the answers it provides, but the questions it forces us to ask. Not the contact it represents, but the possibility of contact it opens. We are the generation that saw the third interstellar visitor and wondered if it was more than rock and ice. We are the ones who detected a radio pulse and asked what it meant. We are the witnesses to jets that shouldn't exist and acceleration that doesn't fit. History will judge whether we were seeing shadows or substance, whether our instruments detected technology or exotic nature, whether this moment was humanity's first glimpse of cosmic companionship or just another fascinating anomaly. But right now, in this moment of not knowing, we are most fully human, most completely alive to possibility, most open to a universe that might contain wonders we haven't imagined. 3i Atlas has given us that openness, that wonder, that humility before the vast unknown. Whatever else it might be, it's already been our teacher, our reminder, our invitation to grow larger than our assumptions. The stars await our understanding. 3i Atlas blazes the trail. We follow with our questions, our instruments, our unquenchable curiosity about what lies beyond the familiar. This is who we are. This is who we're becoming. Watchers of the cosmic deep. Listeners to the universal silence. Seekers of signals in the noise. And sometimes, if we're very lucky and very careful and very patient, finders of something that changes everything. Is 3i Atlas that something? December 19th approaches with its promise of revelation. We watch, we wait, we wonder. The universe prepares its next surprise. And perhaps that's the deepest truth 3i Atlas teaches us. Not that we might find alien technology, not that comets can behave in ways we don't understand, but that the universe itself is alive with possibility. That between the stars in the cold dark we once thought empty, objects journey carrying stories we're only beginning to read. Each interstellar visitor is a library. Chemical compositions tell us about foreign suns. Structural features speak of alien weathering. Trajectories trace paths through galactic history longer than Earth has existed. And perhaps, just perhaps, some carry messages more deliberate than geological record. The ancient Greeks called comets, aster comets, long-haired stars. They saw them as disruptions in the cosmic order, portents of change, messengers from the realm of gods. Were they entirely wrong? 3i Atlas disrupts our cosmic order. It portends change in how we understand interstellar objects, and if it carries technology, it truly is a messenger from something greater than ourselves. But even if it's purely natural, the message remains profound. The universe builds things we haven't imagined. Chemistry works in ways our earthbound laboratories haven't explored. Physics permits structures our models haven't predicted. The cosmos is far more creative than our careful categories suggest. This creativity is perhaps the most important discovery. We've spent centuries building scientific understanding, creating models, establishing laws, drawing boundaries between possible and impossible. 3i Atlas reminds us those boundaries are provisional, that nature doesn't read our textbooks, that surprise is always possible. In our age of supposed scientific completion, when some claim we've discovered all the fundamental laws, 3i Atlas says not yet. There's more to learn, more to discover, more to wonder about. This wonder is not weakness, it's strength. The moment we stop being surprised, we stop learning. The moment we think we understand everything, we understand nothing. 3i Atlas protects us from that arrogance, keeps us humble, keeps us searching. And in that search, we find ourselves. Because ultimately, this isn't just about a strange object passing through our solar system. It's about who we are as a species confronting mystery, about how we respond to the unknown, about what we become when faced with possibilities that exceed our preparation. We become explorers again, not of new continents, but of new concepts, not of unknown seas, but of uncharted possibilities, not conquering, but questioning. 3i Atlas has rekindled that explorer spirit. In laboratories worldwide, scientists are rethinking assumptions. In classrooms, students are asking new questions. In homes, families are discussing what it would mean if we're not alone. The visitor has changed us before we've even determined what it is. That change is already valuable. It breaks us out of routine thinking, forces us to confront our cosmic situation honestly. We're one planet orbiting one star among hundreds of billions. If objects can travel between stars, if chemistry can vary dramatically between systems, if acceleration can occur without visible cause, then our local experience is even more limited than we thought. This limitation isn't depressing, it's liberating. It means there's so much more to discover. So many more surprises waiting, so many more messengers that will challenge our understanding and expand our conception of possible. The radio pulse from 3i Atlas might be a natural phenomenon, but the fact that we're listening for such pulses, that we've built the instruments to detect them, that we care about their meaning, that's the real signal. It's humanity announcing, we're ready to listen, ready to learn, ready to join whatever larger conversation might be happening between the stars. 3i Atlas heard that announcement. Not consciously. Rocks don't have consciousness as far as we know. But in the grand choreography of cosmic motion, this visitor arrived just as we developed the ability to study it properly, just as we built telescopes powerful enough to see its jets, just as we created detectors sensitive enough to hear its whispers. Coincidence? Perhaps. But meaningful coincidence, the kind that suggests the universe might be arranged to promote discovery, that intelligence might be inevitable rather than accidental, that the cosmos wants to be known. This is philosophy, not science. But 3 Atlas bridges that gap. It's absolutely real, a physical object following physical laws, yet it raises questions that transcend physics, questions about meaning and intention and possibility, questions that make us more human in the asking. So as we wait for December 19th, as we prepare our instruments and steady our nerves, we're not just waiting for data. We're waiting to learn something about ourselves, about our capacity for wonder, about our place in the cosmic story, about our future as a species that's learned to look beyond its birth world. 3 Atlas won't answer all these questions. It might not answer any definitively, but it's already served its purpose by making us ask them, by turning our attention outward, by reminding us that the universe is vast and mysterious and absolutely worth exploring. The object speeds outward now, carrying its secrets toward the stars. We'll chase it with our instruments as long as we can, extract every photon of information, build the best understanding possible, but even when it passes beyond our reach, its impact will remain. We'll be different because of 3i Atlas, more aware, more curious, more open to possibilities we hadn't considered, more united in our wonder at the cosmic drama we're privileged to witness. Future interstellar visitors will find a species better prepared for their arrival. We'll have better instruments, better questions, better frameworks for understanding objects that don't fit our categories. We'll be ready because 3i Atlas taught us to be ready, and maybe, just maybe, one of those future visitors will provide the clarity 3i Atlas withholds. We'll be unambiguously artificial. We'll carry a message we can decode. We'll confirm what 3i Atlas only suggests, that intelligence is not unique to Earth. When that day comes, if it comes, we'll look back at 3i Atlas as the beginning, the first hint, the messenger that prepared us for messages to come. But even if that day never comes, even if every interstellar visitor proves naturally explicable, 3i Atlas will still matter, because it changed how we look at the universe, how we think about possibility, how we approach the unknown. It made us better scientists, better philosophers, better humans. The jets are still firing as these words are written. The object is still accelerating through mechanisms we don't fully understand. The mystery is still unfolding. December 19th still approaches with all its promise and uncertainty. We don't know how this story ends, and that's perfect, because the not knowing is what makes us reach, makes us grow, makes us become more than we were. 3i Atlas is that becoming made visible. Our evolution from a species that looks up to a species that understands what it sees. We're not there yet, may never fully be there, but we're closer because of this visitor. Closer to understanding, closer to contact, closer to our cosmic destiny, whatever that might be. The stars don't care about our progress. The universe doesn't notice our tiny efforts to understand its vastness. But we care. We notice. We celebrate every small victory against ignorance. 3i Atlas is such a victory, not because we've solved it, but because we've seen it, documented it, refused to ignore its strangeness, insisted on investigation even when investigation leads to more questions than answers. This is humanity at its most noble, not turning away from difficulty, not settling for easy explanations, not accepting mystery, without attempting understanding. We may be small beneath the infinite sky, our instruments may be primitive compared to what the universe requires, our minds may be too limited to grasp the full truth, but we try, and in trying, we transcend our limitations, become part of the cosmic story, earn our place among the stars not through perfection but through persistence. 3i Atlas recognizes no such effort. It simply follows its path, obeys whatever laws drive it, carries whatever secrets it holds. But we recognize ourselves in our response to it, see who we are and who we're becoming. We are the species that detected an interstellar visitor behaving strangely and said, "We need to understand this." We are the civilization that heard a radio pulse from a cosmic stranger and said, "Could this be a signal?" We are the humans who face the infinite unknown and say, "We will learn what this means." That determination defines us more than any discovery. That curiosity drives us more than any answer. That wonder sustains us through every frustration and failure. 3 Atlas will leave our solar system carrying its mysteries intact or revealed. But it has already given us what we needed most: a reason to look up, to reach out, to imagine possibilities beyond our current understanding. The cosmos is vast, dark, mostly empty, mostly silent. But sometimes, through that darkness and silence, something extraordinary passes by. Something that whispers of worlds beyond ours, of chemistry beyond ours, perhaps of intelligence beyond ours. We are privileged to live in the moment when such whispers can be heard. When humanity has grown capable of detecting interstellar visitors, when we can ask not just "what's that?" but "what does that mean?" 3I Atlas poses that question in the starkest possible terms. What does it mean when a visitor from another star behaves in ways we can't explain? What does it mean when our models break against observed reality? What does it mean when the universe sends us puzzles wrapped in ice and stone and radio waves? It means we're being invited to grow, to expand our understanding, to refine our instruments, to imagine possibilities we haven't imagined, to become the species the cosmos seems to be calling us to become: aware, curious, capable of comprehending wonders we're only beginning to glimpse. 3I Atlas is that invitation written in trajectory and spectral lines and anomalous acceleration. We accept the invitation, we watch, we measure, we wonder, and in wondering, we become more than we were. The universe prepares its next surprise, and we prepare ourselves to meet it. Ready or not, understanding or not, alone or not, we face the cosmic mystery with open eyes and minds. This is our moment. This is our test. This is our opportunity. 3I Atlas blazes across our sky, marking the boundary between what we knew and what we're learning. We follow its path into the unknown, carried by curiosity, sustained by wonder, united in our determination to understand. The journey continues. The questions multiply. The universe expands before us, infinite and welcoming and strange, and we wouldn't have it any other way.